Hello everyone. So I would like to record a video where I go over the problems in the homework set that is due on Thursday, February 9. So some of these questions may be repetitive for some of you. If you have done the work, that is good. If you have not done the work, then you can watch the video. And of course, let me know if you have any questions. All right, so first I'm going to start with homework 1. I'm going to walk you through the whole process. I want to utilize both the tablet and the Python code. So whatever works for us. All right, so let me go over the first problem. So in this problem, you are given a system of two linear equations, and the question asks you to find the solutions. And of course, at this point, you have multiple ways to obtain the solution. You can use substitutions method, eliminations method, as well as Gauss-Jordan eliminations method. And you can solve this problem by hand, or what we have done so far in class up to this point is we can also use Python code to help with the calculation. So therefore, at this point, I'm going to use I'm going to modify the code that we have in class for problem 1. All right, so the system we get is 3x plus 2y equal to -3 and x minus 2y equal to 7. So here's the code, and the first two lines going to be the way it is. We're not going to make any changes for the first two lines of the code. What we're going to modify is the augmented matrix, right? So the entry for the augmented matrix should be 3, 2, and -3. These in the second equations, we have 1, -2, and +7, and you let the code run and see what happens. So it's loading right now. So you get, this is the reduced row echelon form. So this show that x is equal to 1 and y is equal to -3. So let me input the value in here and see what happened. And remember, these problems are generated, randomly generated. Your number will be different from my numbers. Okay, so don't worry about, you see different system than yours. All right, so I'm going to submit the answer and hopefully it's correct. Okay, so moving on to the second equation, right? So it's going to be the same thing, right? We given a system of linear equations, or two linear equations in here, and we're going to modify the code, and hopefully from problem 1 you see that problem 2 is going to be very similar. So therefore what I do is I'm just going to write the augmented matrix on the tablet, and you do your own work and modify the code so that you can obtain the solutions. All right, so in this case, so this is homework 1 and this is problem 2. You have the augmented matrix is of the form -4, 5, this is 60, then 4, 4, -24. And then you can obtain, you can input this into the code and obtain the solutions. All right, so that's for problem 2. Now for problem 3, I have a lot of questions related to problem 3, and I actually went over this in class already, but it doesn't hurt to go over it one more time. So in this case, you have a system of 3x minus y equal to -5, and 9, and the second equation is 9x minus 3y equal to -15. Now, if you notice the second equations, all right, so let me switch back to the tablet one more time. So it's problem 3. So in this problem, again, you have two equations, all right, 3x minus minus y equal to -5, and 9x minus 3y equal to -15. All right, so you have two equations. So I named this equation 1 and equation 2. Now from equation 2, if you divide both sides for 3, right? So divide both sides of equation 2 by positive 3, we obtain that 3x minus y equal to -5. So this resulting equation is exactly the same with the first equation in the system. So therefore you say that the system has infinitely many solutions. So the difference between this system and the one that we did in class is how you present the solutions, right? So in class, we have a free variable, which is usually, we let the free variable to be a parameter t. However, in this case, the system prompts us to write, so if the answer is aligned, right, which is you have two lines stay on top of one another, so therefore you have infinitely many solutions. So the idea here is that what you do is you let x equal to x and you solve for y in terms of x, right? So here I let x equal to x, and for y, what I'm going to do is from here, I'm going to solve for y in terms of x, right? So from this equations, I got that is negative y equal to -3x minus 5. Now multiply both sides for -1, I get y equal to 3x plus 5, right? So I picked this equation because this is an equivalent equation, right? And also it's the same with the first equation in the system. So it's not really matter that which equation I use, either this or this, it should be fine, right? So x is equal to x and y is equal to 3x plus 5. Now let's check the solutions. Right, so that's how you do problem 3. So now let's move on to problem 4. Right, so problem 4 is that you try to pick the correct graph, right? So there are 4 graphs here. And then again, you can utilize Python to help you with the solutions. So in this case, so what I'm going to do is I'm going to input the entry or the coefficients of the system into Python, and then hopefully get something here. So I'm going to modify the code. So I have 1 to 12 and 7, -4 and 12, and then let the system run, and you can see that x is equal to 4 and y is also equal to 4. So therefore the solution of the system written as an order pair is 4, 4. All right, so now how would you choose the correct graph that represents the system here? So the system consists of 2 equations and each equation is aligned. So you know that the intersection point, which is the solution, has to be 4 and 4, right? So x equal to 4, y equal to 4. So therefore you can drop the graph A and graph C. Now the choice is just B and D. Oh, sorry, B or D, right? So here I pick D. Why? Because you look at the system here, right? You can look at what we got here. So let me switch back to the tablet here. So problem 4. So you get the first equation to be x plus 2y equal to 12. And if you solve for y in terms of x, now what do you get? So you get 2y equal to -x plus 12. And y is equal to -1/2 x plus 12. And this is a negative slope, right? So it's trending down. This line is trending down, right? This line is trending down. So therefore, you have this line is trending down. whereas these two lines are trending up. So therefore, you can see that the choice should be D, right? Again, your system may be different from my system, right? So you have to make sure that you analyze the two equations so that you can pick the correct graph. Now let me move on to example problem 5. So problem 5 is going to be the same as problem 4, so I'm going to skip it. Now for problem 6. So problem 6 here, as you can see, for my system, I have two equations here. The system has two equations that is the same, right? So you have infinitely many solutions. Now problem 7. Okay, so you have a system of 3 linear equations. So let's input this into the code. All right, so I'm going to modify the code as follows. So 3 equation, that means you have 3 rows. So the first row is 1, 1, -18. The second row is 5, -3, and -26. And the last row represent the last equation in the system. There's something wrong with my, okay, so this is 14, comma, -10, comma, -60, and you let it run and see what happened. This might be, might have some issues here. So let it run, see what happened. Okay, so x is equal to -10 and y is equal to -8. So let's check it and see what happened. All right, so we have that. We did that correctly. Now let's move on to problem 8. All right, so problem 8, a lot of people also have some issues here. So for this problem, you have a system of 2 linear equations. However, for the second equation, you have a parameter k, or a constant k that you needed to find the value of. Okay, and the question asks you for the above system of equations, to be consistent, what is the value of k? So remember, the system is consistent, means that the system either has one solutions or infinitely many solutions. Okay, so let's solve for this particular system. All right, so let me switch back to the the tablet here. So I have here is problem 8. Right, so my system is -9x plus 9y equal to 15, and -18x plus 18y equal to k. Now, if you notice here, something here, that is the left-hand side for both of this equation look kind of similar if you do some manipulations, right? So for the first equation, if I multiply both sides of the first equation by 2, then the left-hand side of the two equations become the same. Okay, so let me do this. So this is equation 1 and this is equation 2. Okay, now, or for the second equations, if I divided both sides for 2, then I have that the left-hand side of the two equation is also going to be the same, right? So that's what I'm going to do. So here, right, we divide both sides of equation 2 by 2, then we obtain that -9x plus 9y equal to 1/2 times k. right? So divided by 2, that means you multiply by 1/2, or you can write, of course, k over 2, whatever worked for you. So k over 2 here. Right, so the first equations, you have the left-hand side to be negative x plus, negative 9x plus 9y. And for this resulting equation, you have negative x plus, negative 9x plus 9y as well. So the system is consistent if this k over 2 equal to 15, okay? Because so that you have the two lines stay on top of one another. So therefore you have infinitely many solutions, or the system is consistent, okay? So the system is consistent if k over 2 is equal to 15, right? Because if k over 2 is equal to something else, then you have an inconsistent system, right? So the only case that can happen is that k over 2 is equal to 15. Now, from this equation, if you multiply both sides by 2, you're going to obtain that is k equal to 30. Okay, so let me input that into here and see what happened. Right, so I hope that you get the idea of how to solve this problem A. Okay, let's move on to problem 9. All right, so I did this problem in class as well. So hopefully you get that. It should be very straightforward, but let me know if you have any questions, okay? Now let me move on to problem 10. All right, so similar to problem 9, and also we did that in class as well. Okay, so now we're done with homework 1. Let me move on to homework 2. All right, so homework 2, it's going to be very similar to what we have done so far, but now we have a more complicated system. In this case, you have a system of 3 linear equations with 3 unknowns. So for the first equations, let's do, let me switch to here, and let me modify the code in this following manner. So 1, 1, negative 1, positive 4. The second row is negative 5, negative 2, positive 1, and negative 2. The third equations will yield 0, positive 1, negative 1, and negative 3. And you get, this is the reduced row echelon form. So you get x to be equal to 7, y equal to negative 30, and z is equal to negative 27. So this is 7, negative 30, negative 27. All right. So that is the correct answer. All right. So that's problem 1. Problem 2. All right. So for this problem 2, this is the multiple choice questions. So think about what we did in class for unique solutions. System has unique solutions. System has infinitely many solutions, or the system has no solutions. That is the choice that you have to pick for each system. Right, so for this, you can see that x, so let's say this is x, y, and z. So this, in this case, y is equal to negative 6 and z is equal to 8. So you have a unique solution. So here you have a unique solution as well. For this system, this is the reduced row echelon form, and the last row is that the left-hand side is 0 and the right-hand side is equal to 1, which is an inconsistent system. So that you have no solution for the system. And similarly, in this case, you have, even though you have 0 here, but this is 0 on the left and 1 on the right, so the system has no solution as well. All right, so let me move on to problem 3. Right, so problem 3, this is just a reduced row echelon form, and you have to input the elementary row operations. So I will leave this to you to do, because a lot of you have done that very well, and we have spent a lot of time on this already. All right. Problem 5. So again, this is the augmented matrix. You just input this matrix into the code, and you should get the corresponding answer for X, Y, and Z. Problem 6. Problem 6 here. So I did this in class already, but let's go over this one more time. So I have the system here, and I'm going to input this into the code. So this is 2, 2, +1, and +3. Here you get +4, -4, +1, and +1. And the last row should be 6, -2, +2, and +4. Okay, so let the code run. Okay, so now you put the information that you got into the system, and what you need to input here is the reduced row echelon form. Okay, so let me try to do this. So the requirement matrix in the reduced form. So 1, 0, 3/8. B1 is 7/8. A2, 1 is 0, 1. A2, 3 is 1/8. And B2 should be 5/8. And the last row should be a bunch of 0. So 0, 0, right, 0. All right, so this shows that the system has infinitely many solutions, right? And they want us to present these solutions for X and Y, but you have X, Y, and Z. So that means you want to solve for X in terms of Z, and you solve for Y in terms of Z as well. So let me write this on the tablet. So this is homework 2. This is problem 6. Right, so at this point, you have the augmented matrix or the reduced row echelon form of the form 1, 0, 3/8, and 7/8, 0, 1, 1/8, 5/8, and then the last row is 0, 0, 0. Okay, and from this reduced row echelon form, you can write down the system. So the corresponding system is so you have X plus 3/8, Z equal to 7/8, and Y plus 1/8, Z equal to 5/8. All right, and again, from here, you solve for X in terms of Z. So you have X equal to -3/8 Z plus 7/8, and Y is equal to -1/8Z plus 5/8. All right, so input these solutions here. So X is equal to -3/8Z plus 7/8. And Y is -1/8Z plus 5/8. And then that's, sorry, this is 5/8. Okay, this should be the answer. All right. So that's it for problem 6. Let's move on to problem 7. So problem 7 could be very similar to what we have done so far already. You have this given the system, you can write down the augmented matrix and utilize Python to give you the reduced row echelon form. And then from that, you can identify how the type of solutions you have, right? Either it has one solution, infinitely many solution, or no solution. Okay, so let's move on to problem 8. Similar to the last few problems that we have done. Again, use the elementary row operations. That means that you can turn this into the reduced row echelon form. The augmented matrix. Utilize the code to give you the reduced row echelon form, and you obtain X, Y, and Z from there. And problem 9, it's very much the same with what we have done already. Problem 10. All right, so problem 10, again, you have seen this in homework 1 as well. So given the system, this is the reduced row echelon form. This is for the last row, you have 0 on the left and 1 on the right, so the system has no solutions. The system has infinitely many solutions. The system has a unique solution, but be careful with the type of solution with the answer, right? So what is X equal to, what is Y equal to, what is Z equal to, and this one has infinitely many solutions as well. All right, so problem 11, the last problem, very similar to what we have done in this video and also in class. So turn this into a augmented matrix, input that into the code, and let the code run and give you the solutions. All right. So it's just a very quick walkthrough through homework 1 and homework 2. I know it's a very brief video, but I hope this can be helpful for you when you deal with the homework. Please let me know if you have any questions. Okay, and have